Hello, Ritesh sir, am I audible?
Hello, Dr.
Hello.
Ankit.
Yes, sir. Am I audible, sir?
Yes, you are audible. Just wait for a minute. It is going to be recorded.
Okay.
Yes, yes, Ankit. Sir, now you can start.
Sure. Dear participants, Jai Hind and welcome to the day 3 of online FTP on advanced research methodology using SPSS and AMOS. Today's session is based on the use of tools like regression modeling, time series analysis, ARIMA modeling, and factor analysis using SPSS. And the resource person for today's session is Dr. Dushyant Tyagi. Let me introduce Dr. Dushyant Tyagi. Dr. Tyagi is working as assistant professor in the Department of Mathematics and Statistics at Dr. Shakuntala Mishra National Rehabilitation University, Lucknow. He has completed his MSc, MPhil, and PhD in statistics from Department of Statistics, Chaudhry Charan Singh University, Meerut, and possesses 15 years of experience in educating in various institutions of repute like G.B. Pant University of Agriculture and Technology, Institute of Technology and Science, Ghaziabad, International College of Financial Planning, New Delhi, and Lady Shri Ram College for Women, New Delhi. His research area is statistical quality control and computational statistics. He held the responsibility of convener and resource person for 3 AICT-sponsored faculty development programs on advanced data analysis through data analysis softwares. He delivered lectures in more than 40 research methodology workshops. He has 16 research paper publications in reputed international journals and 1 book. He has presented his research work in various national and international conferences and attended several seminars and FDPs of statistics and related areas. He was associated with many government and private universities and institutes as a visiting faculty. We welcome you, sir. Now, over to you, sir. Tyagi, sir.
Thanks, Ankit sir. A very good afternoon to all participants. And thanks, Ritesh sir and the organizers for inviting me. Am I audible?
Yes, sir, you are audible.
Yes, sir, you are audible.
Okay, thanks. So today the responsibility given to me is to discuss some statistical modeling, that is some regression modeling, time series modeling. So without wasting our time, let me share my screen. So first of all, we will discuss the multiple regression analysis. I think the simple linear regression is discussed in the first session. So today we will discuss multiple regression analysis, some theory part of that, not very mathematical in this, because we will do our analysis in our with the help of SPSS, but the terms which we will use, which we will discuss in the result, it should be known to you. Because nowadays, if we are doing the analysis with the help of softwares, so we should know how to interpret the result. So first of all, we will discuss the model and the terms which we will using in this model. Then we will go to regression analysis with the help of SPSS. So the multiple regression model idea is that examining the linear relationship between one dependent variable, that means y, and two or more independent variable. If it is only one independent variable, then it is known as simple linear regression model. And if independent variables are more than two or more, then it is known as multiple linear regression model. So here we are discussing multiple linear regression model, and the regression model is the form of yi equals to beta naught plus beta 1 x1i plus beta 2 x2i and so on till beta k xai. That means here we are assuming that we are having k independent variable, k predictors are there, and then a plus epsilon I. So here y is here, the y is dependent variable, and x1 x2 x3 xk are independent variable. Then beta naught is your intercept, and beta 1 beta 2 beta k are population slope, or we can say population regression coefficient, and epsilon I is random error. So when we do our analysis, maximum time we do our calculation analysis on the basis of sample data. So here we are having the multiple regression equation by which we estimate the value of y. We estimate the value of dependent variable. So the regression model becomes y cap equals to b naught plus b1 x1i plus b2 x2i dash 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 bk xki. So here our b naught is intercept, estimated intercept, and b1 b2 bk are estimated slope coefficient, or we can say that sample regression coefficient, or sometimes we say that sample partial regression coefficient. I will tell you why we say partial regression coefficient. So whenever we perform any statistical analysis, there are some assumptions, and I suggest you all to, before performing any statistical analysis, we have to check that is all the assumptions or more the important assumptions are holding by the data or not. So the assumptions in our multiple regression models are that the error term is normally distributed for each fixed value of x. That means here we are assuming in our model, when we fit a regression model, we assume that x is a fixed value. That means we are having different values of x, but it is depending on the researcher. That means he are changing the he can change the value of x. That means if we are doing any work in the laboratory, so we can change the x according to our model, according to our requirement, and then we can check the change of x in our dependent variable y. So the error term is should be normally distributed for each fixed value of x, and the distribution of y should be normal. Then second assumption, these are only 6 assumptions I mentioned here. Important assumptions are there. There are 9 or 10 assumptions in our multiple regression model, but these are some important assumptions. The mean of all these normal distributions of y at given x lie on a straight line with slope p. When we are fitting a simple linear regression or multiple linear regression, we assume that for given value of x, the y will lie at a straight line with slope b. The mean of error term is 0, and the variance of error term is constant. That means our epsilon should follow normal distribution with mean 0 and variance sigma square. It should be constant at each values of x. x के different values पर ये constant होना चाहिए. This variance does not depend on the values of x. The error terms are uncorrelated. In other words, the observations have been drawn independently. That means the error term should not be auto-correlated, should not be depend on its previous term. If it is depending on its previous term, then your regression model is not so much effective. And the regressors are independent among themselves. That means regressions जो आपके independent variable है, this should not be correlated. So they should not be highly correlated. Okay. So these are the important assumptions we have to check before performing any regression modeling. Statistics associated with multiple regression. The important statistics which we use it is multiple determination, coefficient of multiple determination. The strength of association in multiple regression is measured by the square of the multiple correlation coefficient R square, which is also called the coefficient of multiple determination. Here the R square is the measurement or coefficient by which we measure that our model is good fitted or not, or we can say that our independent variable is contributing to the model or not. Okay, so before after fitting a model, we have to check that is in this model our independent variable is contributing to the model or not. If the independent variable is not contributing to the model, then there is no use of that particular model. But when the independent variable increases, so by the R square will also increase. So to adjust that R square, adjust the increase in the R square due to the increase in the independent variable, we calculate adjusted R square. So R square coefficient of multiple determination is adjusted for the number of independent variable and the sample size to account for the diminishing returns. After the first few variables, the additional independent variable do not much contribute to the model. So that's why we have to adjust the R square. That means when we are dealing with multiple regression analysis, in place of R square, we interpret adjusted R square in place of R square. And the F statistics used to test the null hypothesis that the coefficient of multiple determination in the population R square is 0. That means is the model is good fitted or not. Okay, to test the null hypothesis that the model is good fitted or not, we calculate F statistics. That means here we test the hypothesis, null hypothesis, that beta 1 is equal to beta 2 is equal to beta 3 is equal to 0. That means all betas, all regression coefficients are 0. And if at least one regression coefficient is not equal to 0, then the null hypothesis is rejected in that particular case. So the test statistics has an F distribution. The statistics which we calculate with the help of ANOVA table is follows F distribution with K and n minus K minus 1 degree of freedom. Partial regression coefficient, I told you that BI is the partial regression coefficient, denote the change in the predicted value y cap per unit change in xi when other independent variable are had constant. So here we calculate the sum of square in the dependent variable and sum of square due to the regression and the sum of square due to residual. So these are the formulas to calculate sum of square, and the values of R square is calculated when we divide the sum of square due to regression by the total sum of square. Sum of square due to y is total sum of square. So when we divide the sum of square due to regression divided by total sum of square, we get the value of R square. And to adjust the R square, we calculate adjusted R square, and adjusted R square is equal to R square minus K 1 minus R square divided by n minus K minus 1. Okay. So here in this adjustment, we are using the number of variable, that is K, and the number of observation, that is n. And the range of R square is 0 to 1. But the range of adjusted R square is not 0 to 1. In many cases, it may be negative. If this is the quantity minus K 1 minus R square divided by n minus K minus 1 is greater than R square, then the adjusted R square may be negative. In some analysis, I found that the adjusted R square is negative. So here the null hypothesis is first null hypothesis we use test in regression analysis is R square population is 0. That is beta 1 is equal to beta 2 equals to beta 3 equals to beta k equals to 0. And this is tested by F statistics. That is sum of regression divided by k. That means sum of square due to regression divided by its degree of freedom divided by sum of square due to residual divided by its degree of freedom. And then we test individual beta i's, that is individual independent variable is contributing in the model or not. So for that, we use the test statistics T, and it is calculated by the B value, that is sample partial regression coefficient divided by its standard error, and the T distribution follows. This T statistics follow T distribution with n minus k minus 1 degree of freedom. Here we have taken a small example, that is week. We have for 15 weeks we are having the data: sales, price, advertising. Okay, so the model becomes sales cap equals to B naught plus B1 price plus beta 2 advertising. So this is our result. I will show it to you with the help of SPSS. See here. This is our data set. I think you all know how to enter the data in SPSS file. We are having two tabs in SPSS. One is data view and another is variable view. In variable view, we enter the data variables, the detail of variables on which we are and want to enter the data, that is week, sales, price, and advertising. And in data view, we have entered the data set. So here our units of our data is sales. We can say boxes, how many boxes we are selling in the per week, then the price and advertisement expenditure in hundreds of dollars and price in dollars. So here to perform a multiple linear regression analysis, we have to click on analyze. Then we will get a list of all operations. So here we want to perform regression. Then we will select regression, and then in regression we will select linear, and we will get this new dialog box. In this dialog box, in first box, we will get all the list of all the variables on which we have entered the data. Here in dependent list, we enter the variable which we will perform as dependent variable. So here sale we want as to put as dependent variable, and price and advertising, this both we are assuming as independent variable. So we have shifted this price and advertisement in independent variable list and sales in dependent variable list. Method, we can do stepwise regression. Here we are using enter method. Then there are certain tabs are there. So we will open all the tabs and choose or click those checkbox for which we want the results in our output view. So we want the regression coefficients, estimates of regression coefficients, which we will use for modeling. We want model fit, R square changed. We don't want this. If we want descriptive statistics for all the variables, we have to click this. Collinearity means multi-collinearity. That means all your independent variables are independent or not. So to check the collinearity, we click on this. Darwin-Watson test is that when we want to check that is our error terms is auto-correlated or not, then we will use Darwin-Watson statistics to check this. So we will click this also. Then continue. Plot. Which plot we want here? We will click on histogram here. That means we want to plot the histogram of standardized residual plot, and we can plot this is standardized predicted variable as x-axis, and this is standardized, Z means standardized residual, RESID means residual. So here we are plotting the plot where on x-axis we are putting the standardized predicted value, and on y-axis we are putting the standardized residual. Continue, then save. if you want to save the predicted value, you can save in your data set. If you want to predict the residual, you can save in the data set. So see here, I am choosing the one option, that is unstandardized predicted value and unstandardized residual. I think you all know what is the difference between standardized and unstandardized. When we subtract the mean and divide by standard deviation, it becomes standardized. So here we are saving in our data set unstandardized predicted value and unstandardized residuals. Then continue. Then option, we will click on option, exclude case list wise. Okay, continue. Here, if we are having in our data set some missing values we are having, so there are three options here, that is exclude case list wise. That means if your nowadays the missing data analysis is very important. Okay, so if you want to delete all the cases, exclude all the cases which are having any one missing values and missing values on any of the variable, किसी एक variable पे भी अगर missing value है, so we will exclude all the cases. Exclude case pair wise, that means if we are finding the correlation coefficient in between variable 1 and variable 2, then if in variable 1 and variable 2 for particular case there is no missing, then include that particular cases in our analysis. If variable 3 there is missing value, then no problem, because we are calculating the correlation coefficient between first two variables, so include that particular case in our analysis. So here we calculate the exclude the case pairwise, and if we want to replace the missing value with mean, then we have to select this option, but this is not a good it is not preferred option, replace with mean, because when we replace the missing value with mean, then the standard deviation reduces in our data, and that's why standard error reduces, and our confidence interval, size of confidence interval is also reduces. So we are choosing the exclude case list wise only. Then continue, and we are not using here bootstrapping. So okay, so here our predicted values are saved, the residuals is saved here in our data set because we have chosen these options. Now our output view, this is our output view. See here, the mean of sale is 399.333 and the standard deviation is 63.52 and the total number of observation is 15. So this is this descriptive status of all three variables which we have included in our analysis. Then correlation coefficient, this is between sales and price, it is negative minus 0.443, and advertisement and sales it is positive 0.556, and so on. So these are the three tables which is very useful in our multiple regression. So first table is model summary. Here we have calculated the R square, that is 0.52, and the adjusted R square, that is 0.442. So here we are getting the information that 44% variation in dependent variable can be explained by the variation in independent variable. That means variation दोनों में ही हो रहा है, डिपेंडेंट वेरिएबल में भी वेरिएशन हो रहा है, इंडिपेंडेंस वेरिएबल्स में भी सभी में वेरिएशंस हो रहा है. So the how much variation of dependent variable can be explained by the variation in independence variable, it is 44%. Got it? Adjusted R square. With the help of adjusted R square, we will explain that how much percent of variation in dependent variable can be explained by the variation in independent variable. This is standard error. This is Darwin-Watson value. I will tell you what is Darwin-Watson value later on. it is used to check the autocorrelation in error. Then this is ANOVA table. In this ANOVA table, with the help of this ANOVA table, we are testing the null hypothesis that beta 1 is equal to beta 2 is equal to 0. That means all the regression coefficients, all the partial regression coefficients are 0. This is the null hypothesis. And alternate hypothesis that the at least one regression coefficient is not 0. Yeah. So here we have calculated the f value. So we have to test the null hypothesis. Either we will compare this f statistics, calculated f value, with the tabulated f value and the degree of freedom, numerator degree of freedom 2 and the denominator degree of freedom 12. So it is approximate 3, I think 3 point something. And we may also compare, or we may also take our decision by the p value, this significant denoting the p value. I think you all know what is p value. If you have done any research work, you should know that p value, when we are testing any testing of hypothesis, the p value is the minimum value of level of significance at which we can reject the null hypothesis. That means if here in this particular test, if we are saying that our our level of significance, that is alpha, is 2%, then this significant value is lesser than 2%, so we can reject the null hypothesis. But if we are saying that our alpha is 1%, that means level of significance here we are taking 1%. So here this significant value 0.012 is greater than 0.01. So we will say that we are fails to reject the null hypothesis. That means our decision rule is that if our p value is less than your level of significance, then only you can reject the null hypothesis. Otherwise, you are fails to reject the null hypothesis. In general, we take 5% level of significance. So maximum time we compare the significant value, p value, with 0.05. But according to it is the decision of the researcher that if he want to reduce the level of first we can say probability of type 1 error, then he can reduce till 1% or lesser than that, or increase till 10%. So p value is the minimum level of significance at which you can reject the null hypothesis. So here it is 0.01, and if we are taking the level of significance 5%, so we can say that because the p value is less than alpha, so we can reject the null hypothesis. That means at least one of the independent variable is contributing to the model. Now here we are getting these values. Unstandardized coefficient 306 our intercept, minus 24.975 is our price, and 74.131 is our advertisement coefficient. That means this is beta 1 and this is beta 2. So if we want to check that is these independent variables contributing to the model or not, significant contributing to the model, we check the t value corresponding to these independent variables. So corresponding to p price, the t value is minus 2.306, and corresponding to advertisement, the t value is 2.855. So the thumb rule is that if the t value is more than 2, that means mode of t value is more than 2, that means there is chances to reject the null hypothesis. So in the both the cases, that is first case the null hypothesis that beta 1 is equal to 0, and in this case the null hypothesis that beta 2 is equal to 0. In both the cases we may reject the null hypothesis because the t value is more than the tabulated value, and the significant value is also lesser than 0.05, because in the first case it is 0.04 and the second case it is 0.014. So in both the cases, the p value is less than level of significance, so we can reject the null hypothesis. That means in both model, these both variables, price, advertisement, expenditure, is contributing significant, there is significant contribution in the model. Here, collinearity diagnosis, for this we calculate the eigenvalues and constant. This is histogram of the residual, and it is approximately normally distributed. So we can say that the residual is approximately normally distributed. That is one of our assumption. And this is a scatter diagram between regression standardized predictive values and regression standardized residuals, and it is not in one direction. It is not increasing, so we can say that the regression, the errors are independent. So this all analysis I shown in this PPT also. Here the model becomes this. This is our model here. Sales equals to intercept minus 24.975, that is price, plus 74.131 advertisement. Okay. So with the help of this column, we can form our model, or we can say regression equation. So what the important thing is that what is the interpretation of these regression coefficient minus 24.975? The interpretation of this is that if we are changing 1 unit of price, the average change in sale will be minus 24.975. If we are increasing 1 unit of price, then the sale will decrease by 24.975 units, keeping all other variables constant. Here there is only one more variable, that is advertisement, but if there are k variable, then all other variables should be keeping constant. So here sales will decrease on an average by 24.975 packets per week for each $1 increase in selling price, net of the effect of change due to advertisement. Clear? That means keeping advertisement fixed. And if B2 is equal to 74.131, sales will increase on an average by 74.131 package per week for each $100 increase in advertising, net of the effect of change due to price. So if we want to predict the value with the help of this model, we can put the value of price and advertisement, and we will get the predicted value for the sale. Here we are calculated the R square and the adjusted R square, which we have discussed. This is F statistic, that is 6.531. We have discussed this. Here the null hypothesis is that H0, that beta 1 is equal to beta 2 equals to 0. That means all the regression coefficients are 0. And H1 is that beta 1 and beta 2 both are not both 0. That means at least one beta is not equal to 0. So here this is our table value, or we can say critical value is 3.885, and our calculated value is greater than 3.885. That's why it is lying in rejection region, so we can reject the null hypothesis. This is we have discussed for individual testing of regression coefficient. Here the decision is reject the null hypothesis. Here we are calculating the confidence interval for the population slope beta j, that because we have calculated only the sample regression coefficient. If with the help of sample regression coefficient we want to find out the confidence interval for this regression coefficient, so it be bj, and that means the partial regression coefficient, sample partial regression coefficient plus minus t n minus k minus 1 s bj. So here the t value is 2.1788 for 95% confidence interval. Our standard error for price is 10.832. So the confidence interval is that in 95% time, if we are calculating the confidence interval for price in this particular cases, then in 95% time the partial regression coefficient for price will lie between this interval minus 48.576, because here the sample size is very lesser. That's why the confidence interval is very high. So as we increase the sample size, the confidence interval will be reduced. Now, examination of residual. When we are fitting a regression model, the examination of residual is very important, and a residual is the difference between the observed value of yi and the value predicted by the regression equation yi cap. So yi cap minus yi is known as residual, and the scatter plot of the residual, in which the residuals are plotted against the predicted value yi times or predicted variable, provide useful insight in the examination, the appropriateness of the underlying assumptions and regression model fit. That means if we fit the regression line, if we fit the scatter plot between the residual and predicted values, we get the check the assumptions that is the model is fitting the assumptions or not. The assumptions of the normally distributed error term can be examined by the construction of histogram, as we have discussed. Yeah. The assumption of constant variance of the error terms can be examined by the plotting the residual against the predicted values of the dependent variable yi. See here what is happening as the values predicted values increasing, that means the value of y is increasing, the variation in residual is increasing. That means the residual, the epsilon, is not following the normal distribution with mean 0 and variance sigma square. Here the sigma square is increasing as the value of predicted value y is increasing. So that means this case is known as heteroscedasticity. Okay, and there is one assumption we have mentioned in this also, that the error should be homoscedasticity. That means the error, for error, the value or the variance of error should be same at each value of x की सभी values पर error का variance variability same होनी चाहिए. Okay, but here what is the, if the residual and predicted value y graph is like this, then we say that the error variance term is not constant. Okay, if it is this, then we are when we are plotting residual with respect to time, then, and if we are plotting the residual with respect to predicted value y, and we are getting this type of plot, approximate this type of plot, then we said that the model is good fitted model is appropriate. That means error term is constant, बहुत ज़्यादा वेरिएशन नहीं, मतलब डिफर नहीं है. Then it is multicollinearity. Multicollinearity arises when the intercorrelation among the predictors are very high. When the correlation between the independent variable is very high, then we say that the multicollinearity is there in our data set. And if the multicollinearity is there, so the partial regression coefficient may not be estimated precisely. So regression coefficients आपने B1, B2, B3 calculate किए, these are not precise, and the standard error are likely to be very high. So in that particular case, variability is high in error term, and if variability is high, that means standard error is also high. The magnitude as well as the sign of the partial regression coefficient may change when we change the sample to sample. When we change the sample, then there may be chances that partial regression coefficient sign or magnitude may change very quickly. It becomes difficult to assess the relative importance of the independent variable in explaining the variation in the dependent variable. And the predictor variables may be incorrectly included or removed in the stepwise regression. If there is correlation between the independent variable and you are performing the stepwise regression analysis, so there may be chances that some important independent variable is excluded from the model, and the useless independent variable is included in the model due to multicollinearity. So a simple procedure for adjusting for multicollinearity consists of using only one variable in a highly correlated set of variables. That means a simple method. We are having many methods, but we have discussed only two here. First thing is that if we check the correlation between the independence variable, and we found that these three variables are highly correlated to each other. So what we can do, all include the one variable from the list of three variables in our model and skip two variables. Or other thing what we can do, make one variable with the help of three variables, either weighted mean of all the three variables according to their weight, calculate the weighted mean all the three variables, and then include in the analysis. Or alternatively, the set of independent variable can be transformed into a new set of predictors that are mutually independent by using techniques such as principal component analysis. What we do in principal component analysis or factor analysis, in principal component analysis, we reduce the dimension of the variable. That means we reduce the number of variables. We make the factors or principal components with the help of correlated variables. That means a set of correlated variables, highly correlated variables, becomes a factor. We also check the multicollinearity diagnostic with the help of variance inflation factor. If the variance inflation factor is less than 10, then we say that it is not so much multicollinearity in the data, and we can go forward with the model. And if the multicollinearity variance inflation factor is greater than 10, VIF value is greater than 10, then in that particular case we have to do some corrections, or we can take some changes in the variable, that which variables we have to include in our analysis or which have to exclude. So corrective action, we have to take some corrective action. And the tolerance value we calculate. So the amount of variance in an independent variable that is not explained by the other independent variable. If the other variable explains the lot of variance of a particular independent variable, we have a problem with multicollinearity. Thus, for small values of tolerance indicate problems of the multicollinearity. Okay, that means if the multicollinearity is less than 0.1, if the tolerance value is less than 0.1, then there is a problem of multicollinearity, and if the VIF value is greater than 10, then there is a problem of multicollinearity. So we can check the VIF value or tolerance value to check the multicollinearity. So here in our data set, see here in our result, see here, unstandardized coefficients we have calculated here. Here the unstandardized coefficients are there, t values are there, significant values are there, and their collinearity statistics is there, tolerance and VIF value. So if VIF value is less than 10 or tolerance is greater than 0.1, then we say that there is not so much collinearity in the data in the independent variable. So we have to check this collinearity statistics also when we are fitting any multiple regression model. Yeah, these are important things. We have to check the multiple collinearity in this collinearity statistics. We have to check the Durbin-Watson statistics, which we have calculated here. See here. serially correlated or auto correlated error. That means when we are having the error terms, when we calculate, this is our yi, this is our yi cap, and we calculate the residual r. So, or we can say u. Sometimes we say u, or sometimes we denote it by r. So here we say r1, r2, and rn. So if our error terms is depending on its past error term, then it is the problem is known as autocorrelation. Autocorrelation in error. So for ordinary least square estimator, the method which we use to calculate the partial regression coefficient in this regression analysis is known as ordinary least square method. Is not blue best linear and wise estimator नहीं होते हैं if the expected value of ui is the notation of error here. If ui and uj is expected value of ui and uj is not equal to 0. ठीक है, दैट मीन्स आपके जो स्टैटिस्टिक्स हैं, जो आपके B1 BI हैं, इन सबको बेस्ट लीनियर अनबाइज एस्टिमेटर होने के लिए आपका जो कोवेरियंस बिटवीन ui uj आपका 0 होना चाहिए. In time series data, we often find evidence that the error today is correlated with the past error. This is called serial correlation or autocorrelation of the error. For the efficiency of the prediction, all systematic information needs to be incorporated into the regression model. So here, if your error term, this is your error term, and this is on x-axis we have taken the time. If the curve of is like this, then it means positive autocorrelation. If it is your crosses the line too much, यहाँ पर आप देख रहे हैं points बहुत ज़्यादा line को cross कर रहा है, 6 this is, that means it is negative autocorrelation. If the crossing line is randomly, all points are plotting randomly, then it is no autocorrelation. So if in your data set there is positive autocorrelation or negative autocorrelation, then your estimators are not best linear unbiased estimator. So source of autocorrelation are there, that shocks that affect the dependent variable have effect that the last for more than one period. तो कोई भी अगर शॉक है वो आपके डेटा सेट में रिमेन कर रहा है बहुत लंबे पीरियड तक, then it is the cause of autocorrelation. The shorter the time interval, when you take the time series data or the data for different time period, and your time duration is very lesser, then there may be chances for more autocorrelation in the data set. Monthly data is more likely to have the problem than quarterly, and quarterly is more likely than problem than annually. Good weather is 1 month can have positive effect on yield in the other month. These are so autocorrelates. What is the problem when there is autocorrelation in our data set? So I already told you that best linear unbiased estimator नहीं होते हैं आपका डेटा. जो भी आपने एस्टिमेट, जो आपने रिग्रेशन कोफिशिएंट एस्टिमेट किए हैं सैंपल की हेल्प से, they are not best linear unbiased estimator. If the lag dependent variable is one of the right hand side variable, then ordinary least square estimator is biased and inconsistent. आपके जो एस्टिमेटर होंगे वो inconsistent भी होंगे. The formulas normally used to compute the least square standard error are no longer correct, and coefficient confidence interval and hypothesis test using them will be wrong. So if तो स्टैंडर्ड एरर भी आपका क्या होगा, करेक्ट नहीं होगा, और स्टैंडर्ड एरर की हेल्प से ही आप टेस्टिंग ऑफ हाइपोथेसिस भी करते हैं, बिकॉज आपका जो टी टेस्ट होता है, व्हाट इज टी टेस्ट इक्वल्स टू द बी डिवाइडेड बाय स्टैंडर्ड एरर ऑफ बी. So if your standard error is not correct, that means your testing of hypothesis is also not correct, and your confidence interval will be correct. So testing for autocorrelated error. So here we are discussing only one method, that is Durbin-Watson statistics, to test the autocorrelation. And here the statistics, Durbin-Watson test statistics, is D is calculated with the help of formula that summation UT cap minus UT minus 1 cap whole square divided by UT cap square. So we would could estimate rho by rho means autocorrelation by regressing UT on UT minus 1. So D is approximately equal to 2 into 1 minus rho. Okay. And that means here we are testing the null hypothesis. H naught is that rho is equal to 0. So if rho equals to 0, then D becomes 1. D is approximately equals to 2. And if rho is equal to 1, then D is approximately equal to 0. And if rho equals to minus 1, if rho is equal to minus 1, so it becomes 1 minus minus 1. That means 2. So 2 into 2, 4. That means if your rho is equal to minus 1, then your D becomes approximately equal to 4. So that if your D is approximately equal to 2, then you can say that there is no autocorrelation in our data set. And if D is approximately equal to 0 or nearby 0, then we can say that there is highly positive autocorrelation in our data set. And if D, that means Darwin-Watson value, is approximately equal to 4 or nearby 4, then we say that there is highly significant negative autocorrelation in our data set, in our error term. Got it? So Darwin-Watson test, this is the value which maximum used for testing of autocorrelation in our data set. And if its value is approximately 2, then we can say that there is no autocorrelation in the error term. So the table for critical values of for D are not always readily available. So it is easier to use the p-value that most computer programs provide for D. If p-value, we reject the H naught, when we are taking the decision with p-value, the criteria is same, that if p-value is less than alpha, then reject the null hypothesis, otherwise not. So here our see our results here. This is our result. Here the Darwin-Watson value is 1.683. That means it is approximately, it is nearby 2. So either we will check it by the table value of Darwin-Watson statistics, that is this is lying in critical region or acceptance region. If it is lying in critical region, we reject the null hypothesis. If it is lying in acceptance region, we will say that we are failed to reject the null hypothesis. But here we can see that it is nearby 2, so we can say that there is no significant autocorrelation in our data set. So we should check all these things before applying our regression model for any practical purpose or for any research purpose. Okay, we should check Darwin-Watson statistics, we should check collinearity statistics, and we should check this histogram of regression standardized residual. And if it is approximately normally distributed, it will not come exactly normally distributed. If it is approximately normally distributed, we can say that the assumption of normality of error term is hold here. And see the scatter plot between residual as well as predicted values. And if it is not increasing, the variability is not increasing, or it is random, then we can say that the variability is constant and or observations are independent to each other. Okay, so with the help of these tools, with the help of these statistics, with the help of these graphs, we can check the assumptions which we have discussed in our second or third slides. And these all are important assumptions. What to do if we find the auto-correlated error? Think about changing the model by changing the functional form of including other variable. Re-estimate the model in the hopes of obtaining more efficient estimate and obtaining test statistics. We can use generalized least square method. When there is autocorrelation, then we can use generalized least square method for our estimation. We are not discussing this generalized least square method in detail here. So this is all about multiple regression coefficient. And here in multicollinearity, we have said that what is the way to deal with multicollinearity. So is that a set of independent variable can be transformed. We can say. When there is multicollinearity, we can use principal component analysis by using techniques such as principal component analysis. So here we will discuss the factor analysis, which is the one techniques of dimension reduction. After this, if there any confusion, any query for multiple regression, you may ask. I request to the organizer to unmute the participant if there is any query for multiple regression. Then we will move for the factor analysis. Please raise your hand if there any query in multiple regression or in any of the assumptions which we have discussed here, or any other point about multiple regression. I think there is no query. So we'll move forward for factor analysis. In many research, when we collect the data with the help of questionnaire or with interview, sometimes we collect the data on the variables which are highly correlated. Okay. So that means our number of variables are increased a lot. So to apply the factor analysis, or we can say regression analysis on these particular variables, the multicollinearity problem arises. That means when we ask the questions with same meanings, then their responses will be correlated. And if the responses are correlated to each other, that means the correlation between the independent variable is very high. And that arises the problem of multicollinearity. So to deal with the problem of multicollinearity, we can use factor analysis. And what we do in factor analysis? And factor analysis is a data reduction technique designed to represent a wide range of attributes on a smaller number of dimensions. That means when we are collecting the data on a large number of attributes, large number of variables. So if you want to reduce the number of variables without loss of information, then we use factor analysis. Okay. That means the correlated variables are put in one factor, and the correlation and all the factors are independent to each other. There is no correlation between each factors. This is I want to explain it with the help of example. For example, suppose that a bank asked a large number of questions about a given branch. Consider how the following characteristics might be more parsimoniously represented by just a few factors. So here, we are asking the questions on three or on these 10 variables, that friendliness of the staff, how much you grade. Yeah, if we are asking these questions to a customer of the bank, that how much you rate the friendliness of the staff, how much you rate the time spent in lineup, how much you rate the assistance by telephone, how much you rate distance of bank from home, how much you rate hours of operations, availability of parking, proximity of to other stores where you frequently shop. So in this, these three questions are, we can say, correlated to each other, and we can give these three variables one name, that is service. What's how much you rate the services of this bank. For next four variables, we can ask only one question: how much the visit to bank is convenience to you, and the monthly account fee, charge for withdrawal and deposit, and loan interest rate. These all three questions are correlated to each other, and this is related to cost. So we can ask that how much you satisfy with the cost of this, yeah, charges of this bank. Okay. So in place of asking the question on these 10 variables, we can ask the question on these three factors, and we can make a model for only the three factors in place of 10 variables. What are the benefits for factor analysis? A more concise representation of the marketing situation, and hence communication may be enhanced. Fewer questions may be required on future survey. That means in first survey we have included 10 questions, but with the help of factor analysis we found that just only three factors are sufficient for the future survey. And perceptual map becomes feasible. If your number of variables are lesser, then your perceptual map will be more clear. Ideally, interval data, a rating on 7-point scale regarding the perception of consumers, are required regarding number of features such as those noted above the bank. So in this way, we can use factor analysis to reduce the number of variables. Here we have taken one more example. Here we are evaluating the five types of cars on 13 features. Yeah. So appeals to other people, attractive looking, expensive looking, exciting, very reliable, transit setting, has the latest feature, luxurious, distinctive looking, name you you can trust, conservative looking, family vehicles, and basic transportation. And when we have collected the data on these five vehicles, on the basis of these 13 attributes, we are getting this type of data set. Okay. Car and the 13 variables. Okay. I think this is person, that means second person, so all five cars, and these are the 13 attributes on which we are collecting the data. Here we perform factor analysis, and the important tables are mentioned in this PPT. I will show you, this factor analysis with the help of SPSS also on some data set. Total variance explained. Here the initial eigenvalues are there, and the extraction sum of square loading and rotation sum of square loadings are there. And here we are getting that 3 factors are there. If we are using 3 factors in place of these 13 variables, 13 attributes, if we collect the data on 3 attributes, 3 factors, then we will get the information of 69% information. That means on the cost of 30% information, we are collecting less than 25% variable. We are working on less than 25% factors, because if we are using 13%, 13 variables, then the total variation is 100%. But if in place of 13 variables you are using 3 factors, then first factor is explaining 44% information, second factor is explaining 60% that means we can say 15-16% information, and third factor is explaining 10% information. So with the help of first 3 factors, we are getting 69.822% information. So here, what in this example, what we are doing, we are converting our 13, or we can say reducing our 13 variables into 3 factors. This is component matrix, component score, factor loading also known. This is loading. Here we are getting for the first factor, second factor, third factor. That means the correlation coefficient between, we can say, appeal and first factor is 0.124. Appeal and second factor is 0.880. Appeal and third factor is minus 0.114. Attract the correlation between attract and factor 1 is 0.204, and so on. Then this is the same factor analysis table, total variance. Here we have put it the criteria for making the factor, that we will include the factors for which the eigenvalues greater than 1. See, the values which are greater than 0.5, the factor score which are greater than 0.5 is highlighted here, and you can see that first 2, that is appeal, attract and trend, this is highly correlated with the factor 2. Clear? Then expense, exciting, luxury, distinctive, conserve, family and basic, these are the all the highly correlated with factor 1, and the remaining reliable, latest and trust, this is the highly correlated with factor 3. So what we can do here, we can make these expenses, the list of all the variables attributes which are correlated with the first factor in the first list, the attributes which are correlated with the second factor in the second list, and the attributes which are correlated with the third factor in the third list. Now tell me, what shall these component be called? इन्हें हम क्या कह सकते हैं? First, the group of first factors, को what name we can give to the first factor? Any guess? You may type in the chat box. You may type in the chat box if you want to guess.
Is it a category components? Expensive, exciting, luxury.
Category components. Okay. And second category, second group. So in factor analysis, what we do, we make a
Second is mostly actually it is more towards the subjective. It is not narrowing towards any conclusion.
appeals to others, attractive, trend setting. So these three words are correlated to each other. Reliable, latest feature, trust. These three words are related to each other. So we can put this all three words in one basket that is known as reliable.
Okay.
Reliable, latest feature, and trust. This is in what one basket that is reliable. Appeal
What
to others, attractive looking, trend setting. It's trendy.
can we explore? What about the second category, trending? Some with some more explanation for it.
That means if the car is that means appeal to others. अपील कब करेगी जब when it is trendy, when जब बहुत मतलब ट्रेंड में होगी, ट्रेंड सेटिंग होगी, तभी अपील करेगी. अट्रैक्टिव लुक, ठीक है. एक्सक्लूसिव, एक्सपेंसिव होगा तो मतलब एक्सक्लूसिव है तो एक्सपेंसिव होगा, एक्सपेंसिव है तो एक्सक्लूसिव होगी,
Yes, yes,
लग्जरी होगी.
yes, yes.
ठीक है. डिस्टिंक्ट मतलब आप कोई भी डिस्टिंक्टिव कुछ प्रोडक्ट बन रहा है, अगर कुछ आप कभी कैन से ऑप्टिमम प्रोडक्ट या बन रहा है, एक मॉड डिस्टिंक्टिव है, तो वो एक्सक्लूसिव जरूर होगा. ठीक है. अब ये क्या है, विद द कंजर्वेटिव, फैमिली और बेसिक्स, इन तीनों से क्या आता है, वो नेगेटिवली कोरिलेटेड. सी हियर,
Okay, sir.
here it is negatively correlated. Conservative, family, and basic. In first factor, with the help of with first factor, these four, expensive, exciting, luxury, and distinctive, is positively correlated, but conserve, family, and basic is
Negative.
negatively correlated.
Okay, sir. Okay, sir.
So we have put it not conservative, not family, not basic. जो आपका a car which is exclusive, we cannot say it is basic car.
Yes,
Uska,
sir.
that means it is negatively correlated. Family, it is negatively correlated. Okay. So in this way, we can give the name to a group of variables, and that is known as one factor.
Okay, sir.
So here, calculate the component score. We can calculate the component score, exclusive, trendy. For these three factors, we can calculate the component score. Okay. That means we are adding expensive, exciting, luxury, distinctive scores, and the negative component score for conservative, family, and basics. It is subtracted and divided by 7. Okay, as the trend is, thus we are calculating the average of these three and reliable. So we will get the component score for each factor in this way, and after this we can use this component score for our regression modeling also. Okay. Now I will show you one practical example in one research. Recently we have conducted one research. See here, this is one questionnaire. Is this questionnaire visible to you or not?
Yes, sir. Visual.
So a study of factors affecting small town buyers to clad in buying luxury branded goods in Meerut district. Okay. So the factors which is affecting the small town buyers to buy the luxury brand goods. So we have, this is demographic information we have collected, and after that for 20 or 25 questions we have asked this 7-point scale. We have asked different questions, that is, purchasing luxury goods can be noticed and admired by others. Many people buy luxury fashion goods to show off. If I buy luxury fashion goods, I will choose some those brands known by the people, many people, and so on. So in this way we have asked approximate 25 questions and their satisfaction level and their views on the 25 questions approximate. Okay. So this data is collected here. This is variable view, and here we are having the these all the variables. Purchasing luxury is noticed and admired by others, and so on. I buy a luxury brand because I like the style of the brand design. And the last question in this group is, I think it is worth to pay huge money for the branded products. Okay. So here, can we fit any regression model with the help of these 20 or 25 variables? No, because these all are correlated to each other. Not all, some are correlated to some others, some are correlated to some variables. That means there is the problem of multicollinearity. So if we want to find out the factors which are affecting the buying behavior of the small town or the customers, so we have asked the questions on uh, different ways. We have asked the behavior question, their buying behavior on different uh, attributes, different questions. And now if we want to find out the factors, if we want to check that which factors are affecting their buying behavior, we have to apply here factor analysis. That means we want to reduce the number of variables here. Okay. So to apply the factor analysis here, what we will do, we will click on analyze, then we will select dimension reduction here. Then in dimension reduction, we will select factor. As we click on factor, we will get a new dialog box. And here, in the first list, all the variables are there on which we have entered the data. Now, from the first question, that is purchasing luxury goods, the last question that I think it is worthy. We have shifted all these variables in the variable list on which we want to perform the factor analysis. Then there are certain tabs are there. We will open each tab and select the checkbox. If we want the univariate descriptive analysis for each of the variable, we can select this. Initial solution, we have selected this. Correlation matrix, if you want to find out the correlation between all the variables, we can select this. Yes, KMO and Bartlett test is there to check that is uh, the variables are correlated to each other or not, or can we can say before applying the any data reduction technique, we have to perform this KMO and Bartlett test to check that is the factor analysis will be good tool to apply on this particular data. That means आप उसी डेटा पर फैक्टर एनालिसिस लाएंगे आएंगे जो आपस में कोरिलेटेड होंगे, significant correlation होगा. So KMO test tells us that is the variables are significantly correlated to each other or not. Then continue. Then extraction. Correlation matrix. Display unrotated factor solution. We want unrotated factor solution to display. We want scree plot also to display. This is a important graph in factor analysis. Then extract. If we want to extract only those factors whose eigenvalues are greater than 1, then select this option. If we want to fix the number of factors which we want to extract, then select this option. Clear? That means if we want to say that reduce this 25 variables or 24 variables in 5 factors. So either the eigenvalue is 0.5 for the last factors, it will give the factor score and each and everything for the 5 factors. But maximum time we choose this option that extract the factors for which the eigenvalue is greater than 1. Then continue. Then rotation. For we can say clarity, more clarity, we use Varimax rotation. Continue. Scores. If we want to save the factor scores in our data set, that means if we want to perform the any other regression analysis or further analysis on the factor scores, we can save these factor scores, save as a variable. Display factor score coefficient matrix. Continue. Option. This is how we have to deal with missing values, which we have discussed in and the regression also. The same thing is here. In the coefficient display format, sorted by size, you have to sort by size or suppress the small coefficient. That means we can suppress the values which are less than 0.4 for which the component score is less than 0.4, it will not show you the values. Then OK. And here it is your output. This is the descriptive statistics for all the variables. Here the correlation matrix for all the variables. Yeah. This is the correlation matrix. That means purchasing luxury good is noticed and admired by by others is very less correlated with I choose those luxury brands known by many people, and highly positive correlated with, we can say this, purchasing luxury goods makes one feel superior and unique. I think purchasing luxury goods, luxury brands can give me lot of pleasure. So the first attribute is highly correlated with these attributes. I like a lot of my of luxury in my life. Yeah. So here we are getting the correlation coefficient between all the variables.
Sir, how we will do the interpretation of this factor analysis? We will write in report some idea.
Yes, I will tell it to you one by one. Okay. This is correlation matrix. There is no need to explain this correlation matrix so much. I have shown it to you, and this is the thing which we have to use in our interpretation. Eigenvalues. So here we have chosen those factors for which the eigenvalues are more than 1. So here we are having 8 factors. Total attributes, total variables are 26, and in this total 26 variables, we can convert 26 variables into 8 factors, and these 8 factors explain the 65% variation dispersion in our data set. That means 65% information we are getting with the help of these 8 factors. Okay. We can explain here that we are reducing the 26 variables into 8 factors, and these 8 factors is explaining 65% variation in from the total data sets. This is our scree plot, and we say that from where the L shape we are getting, from where L shape we reduce it. That means we can use 3 only 3 factors here. If we are using 3 factors, then 40% we will experience 40%. But here we are using 6 factors now, 8 factors. So here, till 1, where the eigenvalue is till 1. Now here we are having the component matrix, and so here you can see easily that purchasing luxury goods is noticed and admired by others. This is positively correlated with first factor. But the many people buy luxury brand to show off. This is positively correlated with third and fifth factor. I choose those luxury brands known by many people is positively correlated with first and fourth factor. Okay. Luxury brands are the symbols of social status is positively correlated with first and third factors. So in this way, we have to make the groups that which variables, which attributes are positively or negatively correlated with first factor, which variables are positively correlated with second factor, and so on. Got it? Yeah, in the eighth factor only, there is no component score for the eighth factor which is greater than 0.4, because we have only allowed to write those component score which are greater than 0.4. So in the eighth component there is no score, but then seventh component there is a score. This, it is important for me to have really nice things. With 6 component there is, I think luxury branded goods is bought only by elite classes. Okay, so this is your, and I think price is most important thing to me when I purchase luxury products. Yeah. So the person who is saying that price is more important and only the luxury branded goods is bought by the elite class only. So these are the variables which are correlated to different attributes. Now see here, in our data set, the factor score of all the 8 see here, the factor score of all 8 factors is saved in our data set. Okay, so these are the factor score of 8 factors. Now we can use this factor score for our regression modeling as in our data set, there is a question yes, there is a question that in next 1 year you will purchase the branded luxury brand products or not. So the answer is from 7 point scale. Thus 1 means least possible and 7 means highly possible. So we are saying that purchasing, if we are saying that this is dependent variable, that in next 1 year you will purchase or not, and the buying behavior. So all the 8 factors we will put in the independent variable list, and the next 1 year purchase in your dependent variable list, and we may fit a regression model between these 8 factors and the next year purchase values. So what is the, that means we can find out the important factors the which are affecting the buying behavior of the customers. So here we want to fit a regression model, and we already discussed about regression model. We first of all we will click on analyze, then regression, and then linear. So here our dependent variable is next 1 year purchase. What is your view on your next year purchase? So there is possibility to that you will purchase the branded luxury brand product in the next 1 year or not. And the independent variable list, here we will put the regression factor score for the 8 factors. Okay. Enter method we are using statistics, we are model fit, estimates, Darwin Watson value, continue, plot, z predicted on x, z on y, continue, histogram, we want to plot the histogram of error term also, and normal probability plot, continue, save. We don't want to save predicted values and this, then continue, options, continue. Okay, so see this regression model. Here the adjusted R square is 0.164. That means 16% of the variation you can explain the in dependent variable with the help of independent variable. And thus in the ANOVA table, with the help ANOVA table, we are testing the null hypothesis that model is not good fitted. That means all beta is equal to 0. Against the alternate hypothesis that at least one beta is not equal to 0, and the f value is 8.37, the p value is 0.000, which is less than level of significance. So we can say that the model is good fitted. And see here, these are the unstandardized coefficient, that means beta 1, beta 2, beta 3, beta 4, beta 5, beta 6, beta 7, beta 8. And in this, which are significant? The beta B1 is significant, B2 is significant, B3 is not significant, B4 is significant, B5 is not contributing to the model, B6 is significant, and 7 and 8 is not contributing. That means factor 1, factor 2, factor 4, and factor 6 is significantly contributing to the model. Only these 4 factors are significantly contributing to the model, and other factors are not contributing to the model. Got it? This is our histogram, approximate normal. This is your QQ plot, PP plot, and this is the plot between regression standardized residual and regression standardized predicted values. And we can easily see that the variability is approximately same. Yeah. So in this way, we can use factor analysis when we have collected the data on a large number of variables, and we want to reduce the number of variables for our regression model. Or we can say we can use our principal component analysis or factor analysis when your variables, then when the multicollinearity problem is there in your data set. So you can use the this factor analysis for your regression analysis, or that means for deal with the multicollinearity problem. Yeah. So is there any issue, any query for first two topics, multiple regression and factor analysis? Now we will move forward to discuss the time series modeling. And it is, I can say that time series modeling is a very huge topic, and we cannot discuss incompletely as we have discussed in the regression analysis and factor analysis. But I will try to give you the brief idea of how can we forecast with the help of time series analysis, or how can we use SPSS for the forecast for forecasting the time series data. Here, see one data set. I have just downloaded this data set. Here we have the GDP in current US dollar, India GDP in the rate of current US dollar, population of India and population of China. This is year and this is day. This is year only. So this type of data, if we want to forecast the population of India for next 2 years, 3 years, 4 years, population of China, GDP, or any, we can say, time series data if you want to forecast. So we can use the SPSS software for this analysis. And with the help of this SPSS analysis forecasting tools, we can predict for the future. Okay. Before analyzing this, I will want to discuss some time series in, we can say, notations. See, today I will try to discuss ARIMA modeling for the time series data. So, a time series is defined as a set of quantitative observation arranged in chronological order. Yeah, you all know that if the data is arranged in chronological order, then the data is known as time series data. Or we can say statistically, every observation is a random realization of a stochastic process. That means every observation is a random realization of the process. Yeah. Yeah. We are having these points at zero period. The point value is this. That means at each point is the stochastic process. This is stochastic process. So this is the random realization. These values are the random realization of the stochastic process. So here, features of time series. A time series data may be related to their own past, such as auto-regressive process and moving average process. So auto-regressive process is that process when the observations are depending on its past term. जब आपका डेटा ऑब्जर्वेशन अपने ही पास्ट टर्म पर डिपेंड कर रहा है, देन इट इज नोन एज ऑटो रिग्रेसिव प्रोसेस. And moving average process when your observation are depending on past error term, then it is known as moving average process. They may be subject to deterministic trend. Am I audible?
Yes, sir. Now you are audible.
Okay, thanks, sir. This is the problem of when we are when we show the our screen now, when we share our screen and we show the slides, then we don't get the information that we are connected or not. That's
Yeah, exactly, sir.
that's the problem of Google Meet. Uh, in other platforms, uh, in one side we see that we are connected or not.
Yes, this is again a kind of improvement required in Google Meet.
Yes, Google. Yes, sir. So I think we lost the connection. Should I start from starting, or we have discussed time series? We have to start from here only.
Yes, sir. You are this slides. These time series slide.
Time series. Okay, in this. Okay. So a time series is defined as a set of quantitative observation arranged in chronological order. That means when the observations are collected on chronological order, that means in ascending order of time, then it is known as time series data. And the statistically, every observation is a random realization of stochastic process. That means at each point is the random realization of each. These eight points are the realization of stochastic process. Okay, so features of time series. For when we see the time series data, the time series may be autoregressive process. That means the value observations are depending on its previous terms. The time series may be moving average process. That means the observations are depending on past error terms. There may be chances that there is this trend in the data set, there's seasonality effect in the data set, cyclic variation in the data set, or if it is multivariate data, then the cross correlation may be there. For an example, if we are collecting the data for advertisement expenditure and sales, then if we are expending on in the month of January in advertisement, then their effect may you can see in February or March or in coming months. So tools to identify the underlying behavior of time series. If you have to check the behavior of time series, the first thing you have to check the time series plot, and the second is correlogram. Correlogram is the graph between the autocorrelation coefficient and lag. Lag means if you are having the observation xt, that means t is there 1 2 3, and that means time period is there till n, and xt values are 1 plus 2 x3 x4 और यहाँ पर xn, this is xn. At lag 2, when we are calculating the autocorrelation between xt and plus 3, then it is lag 3. So when we are plotting the graph between rk, that means autocorrelation coefficient at different lag, then it is known as correlogram. And with the help of correlogram, we can find out that is the data set is stationary or not, is the data set having seasonality effect or not, is there any outliers or not. That means correlogram tells us many things in or many properties of our time series data set. So if your this is the correlogram. there are different lags, and this is auto correlation function, ACF, that means auto correlation. So at 0, that means when we are calculating the auto correlation coefficient at lag 0, जब आप xt का xt से correlation auto correlation coefficient निकालेंगे तो वो कितना आएगा, हमेशा 1 आएगा. जब आप x का x से correlation निकालेंगे तो 1 ही आएगा. So if the auto correlation coefficient is not significant, then we can say that the RK follows normal distribution with mean 0 and variance 1 upon n, and that time series is completely random. Okay, so the time series is completely random. If your autocorrelation is like this, that means this is at 0 it is 1 and it is decreasing with a high speed, and in 2 or 3 lag it is insignificant. That means the data is stationary. It is stationary series. Okay. So stationary series often shows short-term correlation by a fairly large value of R1. R1 की वैल्यू बहुत लार्ज होगी, दैट मीन्स फर्स्ट लैग पर, लेकिन उसके बाद जल्दी से वो 0 पर आ जाएगा. ठीक है. इफ इट इज you can say zigzag, that means first negative autocorrelation and positive autocorrelation and negative autocorrelation. This means that there is we can say seasonality effect is there. Okay. If a time series has a tendency to alternate, then the parallelogram also tends to be alternate. यानी कि seasonal, अगर आपका time series alternate है कि values that means summer vacation, winter vacation, summer vacation, winter vacation, summer vacation, winter vacation, तो आपका parallelogram भी क्या होगा, आपका positive negative होगा. This is non-stationary time series. As we are saying that stationary time series में क्या होगा, it will tends to 0, quickly tends to 0, and here in non-stationary time series the parallelogram will tends to 0 after a large number of lags. Yeah. This is also seasonal fluctuation. This is when the outliers are there in our series, then we will get this type of parallelograms. So what is stationarity? Stationarity, a time series process is called strictly stationary if all of its parameters are time invariant. That means mean, variance, the joint distribution of the observation yt plus 1, yt plus 2 and yt is exactly same for yt plus k plus 1, and that means जो properties हैं mean, variance, covariance, वो आपके टाइम पर डिपेंड नहीं कर रही हैं. When the properties is not depending on time, then it is known as stationary process. और आप जब भी कोई फोरकास्टिंग टूल लगाते हैं, सबसे पहले आप अपने टाइम सीरीज को स्टेशनरी प्रोसेस में कन्वर्ट करते हैं, उसके बाद उसमें आप उसमें आप कोई मॉडल फिट करते हैं. अ प्रोसेस कॉल्ड वीकली स्टेशनरी if only the covariance is time dependent and other all things are not depending on time. It is mean reverting, that means when it is stationary time series it is mean reverting. It is finite memory, कोई शॉक होगा तो बहुत जल्दी डाई आउट हो जाएगा. एंड डिफाइंड वेरिएंस, फिक्स वेरिएंस होगा. कैरेक्टरिस्टिक्स ऑफ नॉन स्टेशनरी प्रोसेस होगा तो नॉन मीन रिवर्टिंग होगा, मीन उस मीन पर दोबारा वापस नहीं आएगा, यानी कि उसमें क्या होगा, ट्रेंड होगा. उस टाइम सीरीज में अगर ट्रेंड होगा दैट इज नॉन स्टेशनरी प्रोसेस, वो उस मीन पर दोबारा नहीं आएगी. इनफाइनाइट मेमोरी होगा, अगर कोई शॉक आ गया तो उसका इफेक्ट लॉन्ग पीरियड तक चलेगा. ठीक है. वेरिएंस फिक्स नहीं होगा. प्योर रैंडम प्रोसेस when when the process is not depending on its past term and it is random, it is purely random process. That means variance 0 होगा और मीन जीरो होगा, वेरिएंस फिक्स होगा, देन इट इज रैंडम, प्योर रैंडम प्रोसेस दिस टाइप से। रैंडम वॉक शेयर प्राइस जो होता है उसे हम रैंडम वॉक कहते हैं, दैट इज एक्स टी इक्वल्स टू समीशन जेड आई, ठीक है, यानी कि इट इज द सम ऑफ टी टर्म्स वाइट नॉइज, दैट मीन्स इक्वल्स टू एक्स टी माइनस वन। प्रीवियस जो आपका टर्म है उसमें एक रैंडम वॉक ऐड हो गया है, उसमें एक रैंडम टर्म ऐड हो गई है, देन इट इज बिकम्स अ टूडेज प्रोसेस। तो शेयर प्राइसेस वगैरह को हम क्या कहते हैं, रैंडम वॉक प्रोसेस है। नाउ what we want to discuss today is autoregressive process. When the xt is depending on its previous term with pi coefficient, this is known as autoregressive coefficient. Then it is known as, this is the equation for the first order autocorrelation. That means xt is depending on its just previous term only. And when the xt is depending on last p terms, past p terms, then it is known as that autoregressive process of order p. We are not discussing the much technical. Only the moving average process is that when your xt is depending on its uh, past error term, zt is white noise error. So when the xt is depending on its past error term with coefficient theta, then it is known as moving average process. And if it is only depending on the past one term, yani only the previous term, then it is moving average of order 1. And if it is depending on q term, then q past term, then it is order of q. Why do we need a stationary process? We cannot predict a non-stationary process. Clear? What we have discussed in the last slides, that what is stationary process? Stationary process is that when the characteristics of the distribution is not depending on time. Okay, and to predict, we cannot predict a stationary process. Okay, non-stationary process. To predict any to make any model, time series model, we have to convert the non-stationary series into stationary series. It produces spurious regression. If we are using the stationary series, it produces spurious regression. Okay. What is spurious regression? In this case, आपका आर स्क्वायर बहुत ज़्यादा हाई होगा, डार्विन वॉटसन बहुत लो होगा, तो आर स्क्वायर इज ग्रेटर देन डी होगा। तो टी स्टैटिस्टिक्स इज नॉट वैलिड, उस केस में आपका टी स्टैटिस्टिक्स वैलिड नहीं होगा। दैट मीन्स जो आर, इन सभी केसेस में क्या हो रहा है, आर स्क्वायर बहुत ज़्यादा वैलिड है बट बहुत ज़्यादा हाई है, बट दीज आर ऑल स्प्यूरियस रिग्रेशंस। सो टाइप ऑफ नॉन स्टेशनरी, ट्रेंड स्टेशनरी प्रोसेस है, डिफरेंस स्टेशनरी प्रोसेस, दिस इज ट्रेंड स्टेशनरी प्रोसेस। उसको हमें क्या करना है, अगर जैसे हम नॉन स्टेशनरी और ट्रेंड स्टेशनरी प्रोसेस है, it can be made stationary after detrending. What is detrending? That means yt equals to yt minus 1. When we are doing this differencing, yt minus yt minus 1. So this is what we are doing. We are detrending the process to make the process stationary. Okay, this is known as detrending, differencing. And in this way we can make the non-stationary process into stationary process. Okay. Now the ARIMA modeling which we are going to discuss today. ARIMA is, what is this? This is the combination of autoregressive process, moving average process, and integration, that means differencing. I means integration, that means आप कितना differencing कर रहे हैं अपनी सीरीज को स्टेशनरी बनाने के लिए. So it is P, D and Q. First of all, we will convert our non-stationary process into stationary process. then we check that which AR model for how many previous term, how many lags it is auto correlated, for how many lag it is depending on its error term, and then we will fit ARIMA model of order P, D, and Q. What is the process of fitting ARIMA modeling? Identification stage, estimation stage, diagnosis checking, and forecasting. So we have to identify that how much differentiation we want to convert the data into a stationary process, and we want to calculate the value of P and we want the value of Q. Identify the underlying ARP and MAQ process in the stationary series based on the behavior of the parallelogram. On the basis of parallelogram, we have to check that the value of P and Q. Clear? So if your process is only AR1, then your autocorrelation is, you will find your autocorrelation is like this, and your partial autocorrelation is like this. Okay, AR1, that means only your AR का ऑटो रिग्रेसिव सीरीज की जो पी की वैल्यू है वो किससे आप फाइंड आउट करेंगे? पार्शियल ऑटो कोरिलेशन कर्व से फाइंड आउट करेंगे. अगर आपके पार्शियल ऑटो कोरिलेशन कर्व की केवल वन वैल्यू पर वन लैग पर वो सिग्निफिकेंट है, दैट मीन्स द वैल्यू ऑफ पी इज 1. moving AR2, that means partial auto correlation is significant till lag 2. Here, moving average process, your partial autocorrelation curve is like this. That means it will decrease slowly, and your autocorrelation curve will be significant at lag 1. Clear? And this is MA1 when the negative moving average coefficient. This is MA2 for positive moving average coefficient, and so on. And this is the autocorrelation curve and partial autocorrelation curve when your model is ARIMA. That means first order autoregressive series and first order moving average process. Now I will show you how can we do this with the help of SPSS. So yeah, this is the population data you can download with from the World Data Bank database. So here is the population of India, population of China. So to plot the time series curve, first of all click on analyze, then forecasting, then sequence chart. Okay. Analyze, forecasting, and then sequence chart. Then here we want to plot the sequence chart for India and China population, and time axis is year. So here, can you see this? This is the population of India, and this is the population of China. And here what we are doing, we are crossing the China population and becoming the first highest population country. Okay. in 2020 we are having the data till 2021, and in 2022 we are crossing the China population. Now if you want to forecast this, first of all we have to check that is they are both are having the trend. That means we have to use detrending. Okay, so to detrend, analyze, forecasting, sequence chart, what we have to do, we have to do differencing. You one separate chart for per variable, and we are doing first order differencing. Okay. Okay. ठीक है.
सर प्लीज अनम्यूट कर लीजिए. सर प्लीज अनम्यूट योरसेल्फ. दुष्यंत सर प्लीज अनम्यूट योरसेल्फ.
Okay. Thank you. Yes. So here, see here, this is China population after first differencing, and this is the curve of India population of first differencing. So here we can see it is not the stationary series. They are not showing the stationary series. Somehow this is China population is showing stationary series after first differencing. So we can check the second differencing also. Okay. Analyze, forecasting, sequence chart. Okay, we will plot the autocorrelation first. Autocorrelation of population of India, only population of India we are showing after second order differencing. Okay. Okay, so with the help of autocorrelation curve, we can check that this. Here it is partial or ACF. For one lag, it is significant when we can say that the value of Q, this P is 1, and here the ACF is 3 lags. So there may be chances that it is autocorrelation of order 1. Okay. So analyze, then forecasting, create model. See here, what we can do here, we can population of India or population of India dependent list, variable list. Then either we can fit expert model, that means the SPSS will give you the model by default, that which is the best model for this, or you can fit your model yourself. When you are choosing the expert model, then there is no need to give the value of P, D, and Q. But if you are choosing the ARIMA model, then you have to give the value of P, D, and Q. That means what's the value of P? You can say 1. What's the value of D? 2. And moving average cost is 0, we are saying. Continue. Then the statistic, we want stationary R square here also. We want mean absolute error here. We want the parameters of the estimates here. We want to display the forecast values. Then plot plot residual auto-correlation function, save. If we want to save the predicted values, we can save option. If we want to forecast the value, we can forecast. So here we want to forecast till 2030, then OK, and the result is this. So here we have fitted the ARIMA model with p value 1 and d is 2, that means second order differencing. Here this is the r square, that is 1, stationary r square is 0.63, and maximum absolute percentage error is 0.138, that means it's good. And here we are having the phi value, phi 1 value is 0.956, and 2 differences in there because we have taken the only p at lag 1, that's why we are having the phi 1 values only, because we are not saying that it is moving average. And these are the forecasted values. These are the forecasted values here. This is the forecasted value because it is showing you 1e. If you want the exact value, you can click like this. And this is the forecasted value. Okay. So here we are getting the forecasted value. So in this way, this is the brief overview. How can you apply the ARIMA modeling on your time series data? Now, I have given you some idea. Go through to it, check with your data set, and try to make a good models for different time series. So for this is from my side. If any query, you may ask.
Dear participants, if anyone have any query. So I believe all clear. So thank you so much, sir, for the wonderful session. It was such an insightful and knowledgeable session with practical exposure. In this session, you covers the topics like multiple regression, ANOVA, factor analysis, ARIMA model, time series data. This helps all the participants in making their research more valuable. Thank you, sir. Thank you once again.
Thanks, sir. Thanks to all participants for your patience, and I thanks to Ritesh sir for all your supports and inviting. Thanks a lot, sir.
Thank you, Dushyant sir.
Dear
It was a
participants,
great time to listen you every time, and you are available when I just click you, or when I just call you once at any time. And this is very good session, and people, I think, researchers use this session in their particular research. And special thanks to Dr. Tyagi, and who are available every time when we call in. So thank you, Dr. Tyagi.
Thanks. Okay, sir. Good night.
dear participants, hope you all have filled the attendance feedback form. So I think we should close the session for the day. Ritesh sir, please suggest.
Just a minute, I need to check it. How many participants?
Yes, sir, please check.